The Hoover Dam contains 3.25 million cubic yards of concrete, enough to pave a highway from San Francisco to New York. But here's the problem. If they poured it normally, it would still be curing today. Imagine standing at the edge of the Black Canyon on the Nevada-Arizona border in the 1930s. Before you is the roaring Colorado River, crashing through a narrow gorge with enough force to grind boulders into dust. It is a terrifying sight. The plan is to build a dam across this throat, 726 feet high, holding back the river to create the largest reservoir in the world. It is a project of biblical proportions, but the engineering team, led by Frank Crowe and the U.S. Bureau of Reclamation, faces a terrifying paradox. To stop the river, they must pour a massive amount of concrete. But if they pour that much concrete all at once, it will generate so much internal heat that it will take 125 years to cool down. And as it cools, it will crack and crumble, destroying the dam from the inside out. On this episode of the Master Plan, we are looking at the Hoover Dam, the miracle of the Great Depression, and the genius cooling system that allowed them to tame the Colorado River. To understand the engineering, we have to understand the scale. In the 1930s, the United States was in the grip of the Great Depression. Millions were out of work. The Hoover Dam was not just a construction project. It was a lifeline. But the Colorado River was a monster. It flooded constantly, destroying farmland in California and Arizona. Taming it was the only way to allow the American West to grow. Frank Crowe was the construction superintendent, a man known as a master of logistics. He didn't just need concrete. He needed men. He hired 21,000 men, desperate for work, and brought them to a desolate canyon that reached 120 degrees in the shade. They lived in a company town called Boulder City, with no alcohol and no gambling. But the work was the draw. They were paid in gold dust, and they were given the impossible task of diverting the river. Before they could pour a single drop of concrete, they had to make the river run dry. They drilled 4 tunnels through the canyon walls, massive tunnels 56 feet in diameter. Then, they built 2 massive cofferdams, essentially islands of earth and rock, into the river. They diverted the flow through the tunnels, drained the riverbed, and exposed the rock floor where the dam would sit. It was a race against time, done before the flood season could wash their work away. But once the riverbed was dry, they faced the monster of heat. When concrete cures, it creates a chemical reaction called hydration. It generates heat. If you pour a sidewalk, the heat escapes easily. But if you pour a dam the size of a mountain, the heat gets trapped. The concrete would cook from the inside. It would expand, then contract as it cooled over a century, causing catastrophic cracks that would let the water through. If the dam cracked, it would fail, and the resulting flood would kill millions downstream. The conventional wisdom was to pour the dam in one giant block and just wait 100 years. But they had 7 years. They couldn't wait. They needed a master plan to cheat physics. The solution was radical. They wouldn't just pour concrete. They would embed a refrigerator inside it. This is the genius of the Hoover Dam. The engineers designed a grid of 1-inch steel pipes, totaling 582 miles of pipe, enough to stretch from Las Vegas to Salt Lake City. They laid these pipes inside the forms before the concrete was poured. Then, they pumped ice-cold river water through the pipes at 2,000 gallons per minute. It was the largest air conditioning system in the world. It wasn't cooling the air, it was cooling the stone from the inside. This allowed the concrete to cure without cracking. They poured the dam in 230 individual columns, like giant interlocking Lego bricks, separated by grout keys. The cooling pipes sucked the heat out of the columns in about 2 months instead of 125 years. Once a column cooled, they grouted it to the next column, fusing them into one solid mass. It was a delicate, high-stakes operation. If a pipe burst, it would ruin a section of the dam. If the mix was wrong, it wouldn't set. They had to monitor the temperature constantly, treating the dam like a living patient with a fever. The scale of the pouring was industrial warfare. They built a massive cableway system, steel cables strung across the canyon carrying 20-ton buckets of concrete suspended in the air. Buckets ran back and forth like a giant conveyor belt, dumping the wet mix into the forms 24 hours a day. The noise was deafening: the clash of steel, the roar of the compressors, the thud of the buckets. Workers clung to the canyon walls on scaffolding hundreds of feet above the riverbed, drilling and blasting. It was incredibly dangerous. High scalers were men who dangled over the cliff on ropes, swinging out to knock loose rock with jackhammers. And deep inside the tunnels, they fought a different enemy: carbon monoxide. The tunnels were hot and filled with exhaust from the trucks. If a man passed out in the dark, his lungs filling with gas, he could die before anyone found him. Despite the dangers, they pushed forward. The dam began to rise from the bottom of the canyon, a wall of gray stone defying gravity. The dam was finished 2 years ahead of schedule in 1936. The cooling pipes were cut off and capped, the cavities filled with grout, and the concrete was there to stay. They named it after President Herbert Hoover, though he was deeply unpopular by the end of his term. Over the entrance, they erected 2 massive, winged figures of the Republic, bronze statues, standing 30 feet tall, guarding the structure. Behind the dam, Lake Mead formed, a massive body of water the size of a small state. The dam held. The concrete didn't crack. The master plan had worked. But here is the most incredible fact: the concrete is still curing. Even with the cooling pipes, the core of the dam is still generating heat and slowly settling. 90 years later, it is such a massive object that the chemical process inside is still finishing. It hasn't cracked, but it is still alive in a way, slowly settling into the canyon floor. It continues to release heat, a tiny fraction of what it once did, but enough that it is technically still drying out. Today, the Hoover Dam generates 4 billion kilowatt-hours of hydroelectric power a year, serving Nevada, Arizona, and California. It provides water for millions of acres of farmland. It stands as a testament to American engineering during the darkest economic times in history. When you drive across it, you are driving over a slab of concrete that contains enough material to build a road from San Francisco to New York. But more importantly, you are driving over a slab that acts as a giant refrigerator, a complex machine of embedded pipes and calculated chemistry. They didn't just pour a wall, they baked a cake with the cooling system inside. It is a triumph of logistics over nature. They tamed the Colorado River not with brute force, but with the science of thermodynamics. The Hoover Dam is a masterpiece of the 20th century, a solid mountain of human will that will still be curing long after we are gone. If you enjoyed uncovering the secrets of the still curing concrete and the engineering of the Hoover Dam, please like this video and subscribe to the master plan. Thanks for watching, and I'll see you in the next blueprint.